So the bootloader enables the sketch to upload via the serial port. And the way the bootloader gets onto the chip is if, obviously it's manufactured in when you buy the Arduino board, but if you buy a raw, put this down, will it pick it up? If you buy a raw CPU, it will not have the Arduino bootloader on it, and therefore you can't upload a sketch until you put one on. And the way that's typically done is through a programmer, and the programmer will burn the chip on, and we'll talk a little bit about various ways of connecting that up in a second. And the development environment uses a utility which is part of the Arduino distribution. The utility is called Abradude. And that utility is the piece of software that actually reads the sketch that you've created and passes it on to, via the serial port, onto the chip itself. We'll look, if you want to go into more detail, at that protocol in a second. Different chips require a different boot code because different chips have different capacities. They can hold more memory, or they run at different speeds, and so on. But the most popular one, the one that's on the Arduino Uno or equivalent, is called OptiBoot. This is the most recent bootloader, and it's the one that I think you'll most likely come across when you're using the standard Arduino board. The actual source code for that is on that link. It's on Google Code on OptiBoot. So if you actually ever do want to modify it, or if you're just curious and want to look at it, you can see it there. The Leonardo, because it has USB built into it, and the Due, because it's a 32-bit device, use different bootloaders. So we're primarily going to focus on the one that's in the standard Uno. The actual bootloader code itself is 512 bytes. Any of you know where the term bootloader comes from?
Because you pull yourself up by the bootstraps.
Because you pull yourself up by the bootstraps. The term was first used way back in probably the late 50s. Because, as you know, you use software to load other software. But at some point, you've got to have something which loads the initial software. And that was called the bootstrap loader, and we shortened it to bootloader. The first ones that I came across were about, I think, 16 bytes, or 16 toggles of toggle switches. It's grown to 512 bytes. That's the size of the bootloader on the Arduino. And it connects to your computer via the serial port, and the current bootloaders run at 115K baud, which means that it actually can upload pretty fast. The actual configuration that's used, because it does need to be different depending on the chip that you use, depending on the actual memory size, comes from something called boards.txt. How many of you have actually looked at boards.txt? Boards.txt is a file which is part of the Arduino distribution. It's in the hardware directory, in the place where you installed Arduino. And this is actually what it looks like. And basically, it is the configuration for the bootloader. It has the name of the chip that you're uploading, and these are the names that the Arduino development environment actually puts in the list when you actually go to look at a board. It's actually reading them from boards.txt. It has the upload protocol that the bootloader is using, which for most of the standard boards is called Arduino, which is a slightly modified version of a standard Atmel protocol. The max amount of size of a program file, so when it tells you that your program is too big, when you're compiling something. Anybody compiled something and it says the program is too big? Wow, you guys need to make bigger programs. But you'll see when you do the compilation, it'll say X number of bytes of however many. The amount free is actually given by that, because that number is dependent on not only the chip that is being used, but also by how much space the bootloader itself requires. How fast the serial connection is for the bootloader. There's some other stuff in here which I'm not going to go into. If you have questions on fuses and other stuff, I'll answer it later, but you don't really need to worry about that. Those are doing some low-level programming of things like low-level programming of things like the power configuration of the chip and some other low-level things in the chip. the actual code for the bootloader is given, and this is the name of the file that actually contains the bootloader code, which in this case is OptiBoot. The name of the microcontroller that you're programming, which is the Atmega 328 in this case, the speed that it's running at, 16 megahertz, where all the low-level Arduino code is, what directory it is in, and if you ever want to explore the distribution under the hardware, the kind of standard core files are in a directory called Arduino, but there's a file called variants, where if you use a board like a Teensy, which is a third-party board, or some other special boards, Leonardo has its own core. The name of the folder that's stored in is there. And then some information about the variants, because there are many different kinds of boards. So this boards.txt file is what is used by the development environment, the IDE, to determine how it's going to actually compile the code and pass it into the bootloader. And once it's compiled, typically the way the bootloader is put on is with a programmer. Here is the example programmer. One end of it connects into USB. The other end plugs into that little 6-pin header socket that you typically see on an Arduino board. There are other kinds of programmers, such as this clone programmer who's a small USB from China. Or you can actually use an Arduino board to burn the bootloader. If you need to burn the bootloader, let's say you have to replace the chip and you're using a raw chip, you might want to burn the bootloader. Or if, in the unlikely case, it actually gets damaged somehow and you need to burn it, you can actually use another Arduino board. And if you look at the Arduino website under Arduino ISP, you'll see this file in a tutorial which explains how to connect up a master to a slave Arduino in order to burn the bootloader. And the IDE has, under the Tools menu, an option to burn the bootloader, and you select the kind of programmer that you have. Typically, you would burn a bootloader into a raw chip that perhaps you're building into an embedded solution. And as I say, you can use a standard Arduino if you don't actually have a programmer. I actually built this, I think some of you may have seen it last time, which is an Arduino cloner. And basically it's a little bit similar to the connection that we saw before. There's a standard Arduino board. I've chosen a Leonardo because the Leonardo has a hardware serial connection separate from the USB, and I'll explain why that is the case in a second. And then it has a zero insertion force socket, which is a special socket with a lever on it, which enables the chip to be much more easily connected and disconnected than if you try to plug it into a standard socket. And this Arduino can then program this chip. And because we're going to be making a number of these Arduino clones for the workshops that we're going to be doing, I've designed some software so that it not only burns the bootloader, but it also automatically uploads the test program. As you know, when you buy an Arduino board, it comes with a test sketch, usually the Blink sketch. So I built some software which both burns the bootloader and loads the test sketch. And I'll give you a link to that later if you want. I'm not going to spend time on the circuit for this unless you have questions, but suffice it to say, this is a circuit diagram for a basic, simple Arduino board. So this is kind of the simplest Arduino board, almost the simplest board that you can have. So you have the Arduino chip, you have a crystal which controls its time. This one has an LED, which is a power LED, and another LED, which is the pin 13 LED. And then it has the connection for the serial port, and it also has a connection for the programmer. So that's kind of a very simple circuit. And this is the PCB, which which uses it. So that is actually what this little board at the top is. It is just a very simple Arduino. Because I've been given access to a new precision miller, which makes printed circuit boards, and I need some test stuff, I decided, well, why not make a design a shield that does this? So I took the circuit and turned it into a shield. So this is a similar circuit. So what this does is this plugs into a standard Arduino. The slave chip that you want to program plugs into the top, and then running exactly the same software, it will, in about 10 or 15 seconds, burn the bootloader and run the test. So that's the circuit board. And I'm not. If you have questions about the shield circuit, I will go into it, but of course not. Just say a little bit about the cloning software, which I've called Barbie in honor of the Australian expression, put another shrimp on the Barbie. Anyway.
We got it, yeah.
Okay. This is software which you can load up on an Arduino, and if you connect it up to the circuit that I've shown, will both burn the bootloader on any of the three most common 8-bit boards. So it will automatically detect an Atmega 8, an Atmega 328, 328P, and also actually 168, which are the most common of the boards. It will automatically detect them. It will then, well, I'll show you what it says. So when you run it up, it offers you three options. Press B to burn the bootloader onto the target. Press U to just transfer or upload the test sketch, or press star to do both. So on a raw chip, you press star, it will then burn the bootloader, and then it will upload the test sketch. And because it has, the test sketch is typically the blink LED sketch, if it's worked immediately after the upload's complete, the LED will start blinking. So it's successful. So you're welcome if you're interested to get that from me. This is what you would see if you actually did an upload to burn a bootloader. It will report which bootloading code it's using. It will report the addresses it's using. I didn't talk about the fuse bits, but these low-level settings, it reports on what those settings are. You don't need to change any of that. That's all been defined for you in the boards.txt. And then it reports the pages that it's been able to burn. And then, and if all goes well, it will report that it's finished the burn sequence. And that's it. If there are any errors, it will report the error. The actual test sketch that it uploads is actually stored in this format. I don't know, have any of you actually looked at the intermediate files that Arduino produces when it compiles? They're kind of hidden away because you don't need to look at this stuff, but if you're interested, there's a bunch of stuff there. And the last stage of the build process is to produce what's called a hex file. It's a kind of industry standard format. It was initially developed by Intel for the very first microprocessors, and it's still used. And that format defines the ASCII values in hexadecimal of all of the bytes of the program. And the development environment, actually Arduino, will read that file and load those bytes over the serial port and load them in. Because I wanted the ability to have this test sketch automatically uploaded, I needed some way of actually getting him into an Arduino sketch. So this is the hexadecimal values, as I'm sure you could recognize for the blink sketch. You've all run the blink sketch, so I'm sure that you can see that those are the hexadecimal values. And if you're interested, actually, I've also created a processing sketch which will read any intermediate file. So you can compile whatever test sketch you want. And this processing sketch, if you tell it where your intermediate files are located, I'll explain how to do that later for those that are actually interested in doing this. And the name of the sketch that you're compiling. And this will automatically convert those intermediate files into the file that's used by the sketch we looked at before, by the Barbie sketch. The Barbie sketch will read the output of that and burn that onto the chip. So, there is a quick run-through of the Arduino bootloader. Are there any questions?
You briefly referenced the Hex file there. Is there any, and it may be a bit off topic, are there any disassemblers that you get that would actually show you the opcodes and stuff?
There is a disassembler that is actually part of the tool set. And that disassembler uses one of the intermediate files that's automatically produced. And the disassembler is called AVR obj dump. AVR dash or underscore obj dump. And if you run that, it will read the intermediate files that are produced and show you the source code intermixed with the assembly code. And it's a great way if you're interested in learning a little bit about assembly, of seeing how it works, or if you need to optimize your code and you want a mixture of assembler and the Arduino code, then AVR obj dump is a good tool to use.
Again, it may be a little bit off topic. Are you able to breakpoint on Arduino?
No,
Anything like that?
there is no real-time debugging in the Arduino environment. There is some real-time debugging in some of the Atmel tools, but that's beyond the scope of what you can do with Arduino. But because the Arduino environment is so simple, the instruction set is simple, the amount of memory is simple, it's usually pretty easy to logically work out what's going on. And if you're really stuck, although you don't have breakpoints, so you can't actually see in real time what's happening, by looking at the output of the object dump with the source code, you can more often than not figure out what's going on. Any other questions on anything that I've discussed? So, thank you very much.